And good morning once more. I don't know if online we are set. Can anyone just confirm whether those colleagues that are online are set and they can hear us? Yes, sir. Okay, thank you. Good morning to our distinguished guests, members of the college executive, esteemed colleagues and supervisors, researchers, our postgraduate students, and ladies and gentlemen. I trust that you're doing well this morning, and I'm glad that at least Joburg weather is quite nice today, so we're not going to be freezing throughout the day. So it's my pleasure to welcome you to the first day of our 5th postgraduate student symposium, our 5th. So it means we've been trying, and I think we've been succeeding. The only thing that we need to get is the numbers to increase. But it's interesting to see that over the years, we have continuously managed to host this symposium. So this is our 5th symposium, and the theme for today's or this year's symposium is Transforming Industries Through Data, Design, and Natural Sciences. So this theme actually shows us that the type of research that we do should have impact. You should recognize the type of work that you're doing and ask yourself, what is it that I'm aiming to achieve at the end of the day? Am I doing this research just to pack it, or do I want it to have a meaning? I mean, we are faced with several challenges globally, and let that type of research that you're doing be the one that would, even if it's not to solve all the problems, but let it have impact and then bring about something that is important. So, on behalf of the organizing committee, let me thank and appreciate each and every one of you for joining. We know that we do have a lot of commitments. You could be doing something, but I think you actually decided to dedicate your time for this session, and that is appreciated. So we look forward to a very interesting 2 days of stimulating presentations from our students, our postdoctoral students, and also the scholarly discussions that would come through, and the network that is going to be initiated because of these engagements. So I think that will be great for us to actually celebrate the excellent research that all colleagues are doing at this point across the college. Before we commence, I would like to draw attention to a few housekeeping rules. The first one, obviously, we just need to make sure that our phones are on silence so that they don't disturb the proceedings. Secondly, we need to remain mindful of the program schedule because we have a lot of presenters, so let's try to stick to time. Those who will be presenting, whether it's face-to-face or online, let's be mindful of the time that is scheduled. And also, if we are asking questions, let a question end with a question mark, and we don't need a paragraph for questions. So just be straight to the point, because other people, when they ask questions, they actually want to present, and you're like thinking, why didn't we put them on the program actually? So let a question end with a question mark, and a comment also, let's not lengthen the comments so that we can make sure that we stick to the time that is allocated. Finally, I would like to encourage participation by shortening the questions and comments. We're not saying people should not shy away from participating. Let's also participate. So the restrooms, for those that are new or not familiar with the place, if you go to the left, you will find the gents and ladies' restrooms. I think you can also utilize that door. And then if you go around, I think on the second floor, also there are restrooms as well as the first floor. And you can ask others to just show you in case you are not aware. Without wasting time, it is now my honor to invite our school director, Professor Siminya, the school director of the Ecological and Human Sustainability School, to deliver the official opening and welcome address for the day on behalf of the Executive Committee of the college. Prof. Siminya, over to you. I'm not sure if she has joined.
Yes, I am here, Prof. Masebe. Thank you so much.
Over to you, Prof.
Thank you so much. My apologies, colleagues. I'm not camera ready. I will not be able to show my face. Apologies about that. Good morning, colleagues. Good morning, everybody who has joined us online or even physically on campus. Thank you, colleagues. It is my pleasure to welcome you all to this 5th annual postgraduate student symposium. I am here on behalf of the college, extending a warm welcome to each and every one of you colleagues. We are here today to celebrate scholarship, innovation, and pursuit of knowledge. Colleagues, it is also a celebration of our postgraduate students whose dedication, resilience, and commitment to research have brought them to this platform where they will be showcasing their work. And research, colleagues, drives innovation, informs policy, addresses societal challenges, and contributes to sustainable development. More importantly, it equips us with the evidence needed to improve lives and build stronger communities. As college colleagues, as a college, we are proud that our students are contributing to these goals through the research that they are doing, because they will be showcasing how their research addresses real-world challenges, whether in environmental sustainability, biodiversity, biotechnology, food security, public health, agriculture, and any other fields that they will be presenting on. So this symposium today, colleagues, will provide more than just an opportunity for colleagues to present their findings. It is a platform of learning, networking, as Prof. Matebe has already indicated, and they will be receiving constructive feedback and developing the confidence required to communicate scientific knowledge effectively. I therefore encourage our student presenters to embrace today's discussions, ask questions, and view every comment as an opportunity to strengthen your research. Colleagues, I would also like to acknowledge and thank our supervisors, the academic support who have guiding and supervising the students for your mentorship, guidance, your unwavering support. Because by doing that, colleagues, you are playing your role of developing the next generation of researchers. The achievement we celebrate today are also a reflection of your dedication and academic excellency. And I have seen that we have sponsors in Gaba Biotech and the Thermo Fisher Scientific. I would like to acknowledge you and thank you for partnering with us and the support that you're giving to our student development. A warm welcome to you, and a special welcome goes to our guest speaker, Ms. Marie Rande, who will be sharing her insights on a postgraduate journey in a presentation titled Beyond the Bench, Lessons Learned from her postgraduate journey. We are looking forward to hearing your experiences and the valuable lessons that you will be inspiring our students as they navigate their own research journeys. To all of your colleagues, everybody that will be presenting, I wish you all the best with your presentation, and I believe that everyone will find today's program both enriching and inspiring. Colleagues, you are all welcome. Thank you, Program Director. Thank you, colleagues.
Thank you so much, Prof. Semenya, for your welcoming speech, and also for reminding our students, our researchers, our guests, the importance of being here today, and also the importance of doing research that has got innovative potential. We really appreciate, and we know that you could not join us, but nevertheless, we appreciate that you could still make time to open the session for us and welcome our guest. Thank you so much, Prof. Okay, without wasting time, it's my pleasure to introduce our next speaker, Dr. Wari Rande, who is a lecturer at Uppsala University in Sweden, where she is actively involved in both undergrad teaching and research. Her research focuses on the selection and dissemination of antibiotic resistance in environmental settings, particularly in wastewater systems. And the current work also includes investigation of Legionella in wastewaters from the paper industry, contributing to our understanding of environmental microbiology and public health. She completed her undergrad studies in Copenhagen, Denmark, and undertook a master's research in Aberdeen, Scotland. She earned her PhD at Uppsala University, where her research examined the genetics of aging Salmonella colonies. Following her doctoral studies, Dr. Rande pursued postdoctoral research in the United States at Washington State University, where she investigated the interactions between Salmonella and human epithelial cells She subsequently completed a second postdoctoral fellowship at Karolinska Institute in Stockholm, Sweden, focusing on the survival of Salmonella within macrophages. Dr. Rande's distinguished academic journey reflects extensive international experience and significant contribution to the fields of microbiology, antibiotic resistance, and bacterial pathogenesis. Please join me in warmly welcoming Dr. Marie Rande. Over to you, Doc.
Thank you very much. I hope you can hear me. Hi, and can you see me also maybe? Let's see if I can figure out.
Yes, we can hear you.
Great.
And we can see you. Thank you. Do you want to share your presentation?
Yes, I will see if I can figure out how to do that.
Okay.
Oh my God. I'm very used to using Zoom, not so used to using Teams. Let's hope. Okay, share.
Yes, I think that's where you should go.
Yeah, and then it wants to add a background. I don't need to do that, do I? Why is it not sharing? Maybe my husband knows how to share in Teams. Yeah, I have found the share button. Then what?
Did you find the share option?
Yeah, I found the share button, but I can't press any window to share. It's really weird. It wants to do some security setting. Maybe that's the problem. Oh my goodness, I'm sorry.
Is there anyone who can share the presentation? If you could share the presentation, maybe we can project it from our side. Will it be possible? Is it possible to do that? She left the meeting? Okay. Annelien, do you have her email address? Maybe she can drop it and then we can project it here. You want to help?
Okay, yeah. Am I sharing my screen now?
Can you see it?
Can you see something now? Do you see my slide or do you see something?
They'll just help us now.
Yes, we can see your slides.
Okay, but how do we then project them? They say the Teams thing is at the back. I don't know how we're going to do that.
Mm-hmm. Is it better if I try to share the presentation with Annelien?
Yes, I think let's rather do that, and then they.
Okay, I'll try to send it.
No, we can see it. Yes.
Oh, yes, we can see it. Yeah, thank you. You can continue.
Okay, great. Well, sorry about that. Thank you so much for inviting me. It's super fun to be here, even though I am quite far away. Thank you, Annelien, for this contact. So I know that you're going to hear a lot about science today, later, when you present your work and everything. So I'm not going to talk about my science. I'm going to speak about more my journey and how I chose what I chose to do in my career, and all the different weird circumstances that led to where I am today. And hopefully I can inspire you with some ideas, even though we're of course all different, and nothing that I can say is going to be 100% true for any of you, of course. But kind of the main message, I think, is that just follow your dreams, and don't be too disappointed if they don't work out exactly like you planned, because it will be pretty good in the end anyway. And I hope that my journey will prove that to you. So this is kind of a cliche statement, but I actually never planned 100%. I just did what I thought sounded fun at the moment, and I followed opportunities, and I quickly realized that people are more important than the actual publications or results that you get in the lab, even though, of course, science is what drives us all. And as you can see in the bottom of my slide, I have done quite a journey when it comes to different countries that I've lived in. And this is all thanks to science. And I'm very happy about this journey. And this has been what has inspired me to continue in science, that you're allowed to travel and meet new people and make new experiences. So a little bit about myself before I go into my journey. I'm from Sweden, right above you. Actually, you just fly straight north, you'll get here. It is actually 30 degrees warm now, so it's not too bad, but Sweden is a cold country, so we do have a lot of snow in the winter, but it's quite nice. In the summer, it's bright all night long because we have the midnight sun, and not as pleasant in the winter where it's dark all day long. All right. I have a family, my husband and 3 kids, and we live on a farm. So we have horses and cats and sheep, rabbits. And if I don't spend my time in the lab or at my farm, I like to do some exercises. So for example, running. That picture on the right is from last summer when I did a half marathon across the bridge that's connecting Denmark and Sweden. So that was it about me. Or actually, you will hear a lot more, but a bit of a background. Okay, so what does Icelandic horses have to do with the science career in microbiology? For me, everything. So when I ended high school, so I was 18 or 19, I decided to follow my dream and travel to Iceland because I was already then in love with these little ponies that they have there. The Vikings brought them there, and the Vikings used them for transportation, and now we use them as riding horses, mostly for fun. They're an amazing horse breed, and I just wanted to experience kind of where they're from. So I moved and I stayed for 1 year on Iceland. Of course, I didn't do any science there, but this is why I then had the journey that I had. So when I was on Iceland, I learned to follow my dreams. I learned to work hard. I had a lot of fun, but I also had a lot of challenges. And most importantly, I met a lot of people from different countries. And I stayed very close with 2 Danish girls. And that, I think, is why I chose to do my undergraduate studies in Copenhagen. And that's what shaped my whole scientific career, I would say. So I moved, of course, Copenhagen in Denmark is not that far away, but it's still, it is a new country. They have a slightly different culture. The language is quite new. And I wanted to study animals, so I started studying agronomy, but I learned quite quickly that I actually loved bacteria. And even though I do love animals, you probably figured out that already. I of course like animals a lot, but what I wanted to study and get super into, that was actually bacteria. I think it was thanks to this professor that we had in general bacteriology, I guess, in the one of the first courses on my program. That also shows you how inspiring professors can really shape our lives, right? So then, instead of continuing with agronomy for my master's, I changed to biotechnology. And I met really friends for life here. I go to Denmark very often. I even imported my husband from Denmark. This was, of course, my first science network as well. So I still have people that I did my bachelor's thesis with, that I still write to sometimes if I have some questions or just thoughts. And then I got an opportunity to travel again, actually. So I didn't complete my full undergraduates in Denmark. I went to Scotland, Aberdeen in Scotland, to do my master's thesis. And this was with an Erasmus scholarship. So I was lucky to get this scholarship so that I could travel. So I really just jumped onto this opportunity. And I got so many good experiences. This was where I first really understood that I need to stay in science. I really just fell in love with lab work. And this was, again, bacteria. I worked on E. coli and some channels in their membrane that they open when they feel osmotic stress. Very nitty-gritty, but super interesting. This was where I first also saw how the people in the lab, what kind of, you all know, in a PhD lab, you're there all the time, right? And you live with your colleagues almost, it feels like sometimes. And even though I was just a master student at this point, there were so many PhD students in this lab. It was a really big lab. So I really got into this science career. And then the Scottish also have a really nice culture around hanging out outside of the lab. So when it started becoming close to 5 o'clock, there was always somebody shouting "pub" over the lab benches, and people would start, putting their stuff together, and we would meet at the pub instead. So it was also a really social experience. But mainly, I fell in love with lab work, actually. All right, so then I had to decide, where should I do my PhD? I actually considered staying in Aberdeen, but they only had a 3-year PhD program, and we have 5-year in Sweden. I also considered Denmark, but they didn't have any money for me in the lab that I wanted to go. So there was a few circumstances that made it so that I actually went back to Sweden. And I moved to Uppsala, which is one of Sweden's oldest universities. It has very nice sort of student life. Everyone is out on these little student restaurants, student pubs, and hanging out quite a lot in the town. When I first moved here, it was not so many other people. It felt like it was mostly students in town. There's been more and more people moving in with businesses, and so other employments are possible as well. But the university is still quite a big part of this town. And I had a very good supervisor. And that, of course, you know as well how important that is. So I was lucky with that. He really took me in. He felt like almost like a science dad or something. And so I got a really good sort of base in research, and I was very happy. And I started teaching also, which I realized that I enjoy quite a lot as well. We have 20% teaching for all PhD students at Uppsala University. So about one of these 5 years, but spread out over the years, is allocated to teaching. I think that's quite good. At the time, it could sometimes feel like it steals your research time, and it does, of course, in a way. But on the other hand, it gives you so many other experiences. And I think it's one of the best ways to learn yourself is to try to teach someone else, right? Because then you really have to explain it and understand it well yourself. And during my PhD in Uppsala, I was again super lucky to have a co-supervisor who was from UC Davis in California in the US. And so my supervisor in Sweden, he wanted me to learn some more bacterial genetics techniques that, so he sent me to the US for 3 months. So again, I got to experience a new lab culture, so different in each country. It doesn't even have to be a country you travel to, I think. You can just go to the lab next door and it will be different, right? But this was very different, and I found new friends again and experienced so many nice things, and also, of course, learned these genetic methods that were good to have in my experience as well later. And then I managed to finish my PhD. It took a very long time because I also had 3 kids in the meantime. So I started my family and did my PhD at the same time. That I know is not possible in some countries, but I'm lucky that, it is possible to do it in Sweden. You get extra time if you have to stay home with your kids. So it was possible to have the kids at the same time. So then I decided to still stay in science. I was still in love with lab work and especially bacteria. So I started talking to people. Okay, where should I go? The world was open again. And one of my colleagues from Uppsala, he had done his postdoc in the US together with a young woman. She had now started her own lab she was very new actually. I became, together with another postdoc, her first people that she had in her lab. And she was in Washington State in the US, so very western side of the US, but very far from Seattle. So it was like 5 hours drive from Seattle. So it was in the middle of redneck land, I would say, and pretty challenging place to be. It was just wheat fields everywhere, and then this tiny town with the university. So I didn't really know what I signed up for, I think, when I went into this, but it turned out pretty good. I learned all these new techniques. I got to work with my favorite bacteria, which is Salmonella. I got to learn how to grow human cells and infect them with Salmonella. I had never grown any eukaryotic cells before, so that was super fun. Here I again got loads of friends that I still keep in touch with. And I, of course, developed a lot of independence here, because when you become a postdoc, of course, you're not as leaning on your PhD or on your supervisor as you are during your PhD. This was, of course, super challenging. I was in despair sometimes, when experiments don't work and you don't really know what to do. And I also moved with my whole family. I had 3 little kids at home, but I was lucky enough that my husband was very supportive, and he took most of the responsibility for the kids and the home. So I could spend a lot of time in the lab. I would say that these 2 years that I spent in the US, that's probably when I've had the most time to focus on my research. I didn't teach at all, even though I just said that I like teaching, and I do. That was not a lie, but it does take time. So I didn't teach. I didn't have any responsibilities in the university world, and I didn't have so many other things. I actually, as I had just moved to another country again, I didn't even have these responsibilities to visit family and friends because we were so far away. So I had a lot of time to dedicate to science. So that was super fun, actually, to just be able to dig really deep into science. So that's something that I would really encourage you to do a postdoc. That's probably the best years in when you think of just the science. Then I moved home and did a second postdoc in Sweden, not Uppsala this time, but Karolinska Institute in Stockholm. It was a very small group. It was just one PI and one PhD student, and then me. So that was a new level of independence where I was feeling quite alone sometimes. And in the end, I actually moved back to Uppsala to do my lab work here because it didn't really work out to commute. Also, I'll tell you a bit more why later. But it was all in all a fun experience as well. And I again got to know a new lab culture and made some friends. All right, so I also promised to tell you some of the lessons that I had learned, and not only the sunshine story of me moving around the world, having fun in the lab. So what I wanted to do when I was growing up was actually to become a vet. But I don't know, I wasn't studying too well in high school, so I got 2 bad grades to get into vet school. That's one of the hardest schools to get into here in Sweden, very popular. So that's why I picked agronomy. I thought that was second best. I at least got to study animals, which I then realized I didn't want to do actually. So maybe it was good that I didn't get into vet school. And then when I was choosing between Uppsala and Copenhagen, I think that was really thanks to my Iceland experience that I already told you that I actually dared to move to Copenhagen. I'm very, very thankful for that. So this was more just to really encourage you that you don't have to have all the plans from the beginning. Just take it one step at a time and, you know, see what happens. You can change your mind. And failed experiments, I'm sure you all know about them. So when I came about halfway through my PhD, we realized that we had done all the experiments kind of the wrong way. So I had wasted almost 2 years. And yeah, you can imagine how that felt. I had no publication in sight, and we have this quite strong requirement for minimum 3 publications when you finish your PhD. So I started to feel quite stressed and down. But luckily, I had such a good PhD supervisor. So together we figured out a way. And then once we got into doing the experiments the right way, it was quite quick. And I actually got. It took 2 more years though, so quite quick was very much exaggeration. But after that, I got 2 more publications. But the first one didn't come out until 4 years after I started. So, you know, just don't give up. Failure is part of it, and just keep pushing, and you'll get there, I think. Yeah, another thing with science, you know how it is with money also. So this I experienced when I wanted to go on my postdoc. So, well, actually, first I wanted to tell you when I chose my PhD, I wanted to do it in Copenhagen in the very beginning, but there was no money in the lab that I went to. So already there, it was money partly that made my decisions for me. So this PhD supervisor in Uppsala had money, so I had that opportunity there, even though I didn't know Uppsala, I didn't know him, I didn't know the lab or anything, but it turned out well anyway. But sometimes, yeah, you can't decide exactly how you want it. And when I wanted to do my postdoc then, that's where it really started stressing me out. So I was applying for all of these stipends because I couldn't go without money. I tried for this Marie Curie, it's some French stipend, I didn't get it. Tried with a few more, our own local Swedish one, I didn't get that one either. I tried with the EMBO one, which is a really prestigious European one. I got singled out to interview, and then everyone said, oh yeah, if you get to the interview stage, you're gonna get it. That's almost 100%. So I was really happy, and I went to this interview, and there was this old German, very, I don't know, grumpy man, and he just looked at me, and then he said, how are you gonna do this with 3 kids? How is a woman gonna be able to do this? And he decided that I could not have the money. So that was really like a setback, and I felt like, okay, maybe I can't do it. Maybe it's too much to go to another country with a whole family, and maybe it's not also fair on the kids to move them, or, you know. So I started thinking maybe I should just stay in Sweden and do something completely different. But then I got this small grant that left me at least 1 year I could go to the US. I got it very late, so I had even started to think of other plans in the meantime. But then when I got the letter from Benegren that I got some money for 1 year, then I thought, okay, let's do it. And I went, and of course I don't regret that at all. I wouldn't have had these. This is actually my PhD or my postdoc supervisor on the top. When she came to visit me just a year ago in Uppsala, so we're still friends as well. And I, like you see, I'm wearing a sari on 2 of the pictures. One of them is from India, one is from Sri Lanka, and that's all visiting friends that I've met during my science career. In Sri Lanka is my colleague from my master time already. And then during my PhD, I met the Indian girl who got married of course, in India. And all the experiences running and doing all sorts of weird sports with my colleagues. That would not have happened if I didn't say yes and went on all these trips. So even if it doesn't always turn out the way we plan, most of the time it becomes pretty good, I think. And like I said before, science is so much more than just the publications. Of course you need them, and of course you want to make your science heard. Like we heard in the introduction, I thought that was really nice words, that we have to think about the research we do, and of course we want it to reach out and actually be important. But I think in order to do that and achieve something like that in research, you have to have fun as well, and you have to feel good. So these are just some pictures from very long time ago when we used to have dress-up parties. It's my PhD supervisor and his group dressing up as the 7 deadly sins in the middle. And then just this January, he turned 70, and we managed to get almost all of his past PhD students together. That's the picture in the right down corner. And we meet still very often to have dinner together. So we're still a little family, this PhD group that I had now many years ago. So that is also something that I think is important to think about, that science is so much more than the actual research in the lab and the publications. And just enjoy the journey. I have really liked to go to conferences, for example. Here are a few pictures from different conferences, one in Boston and one somewhere else in the US, I don't remember, maybe San Diego, I think. And yeah, it's been so fun to go and see what other people do in their research and meet people and be able to share what you do yourself. I'm sure you have gone to conferences already, but if you get the opportunity, just do that, both for the science and for the social network that you build up. That's also something that can help you so much if you want to do a postdoc afterwards, for example. If you have some connections with somebody you met, it's so much easier to be able to go. Maybe you can even get some help with this money issue if you happen to know the right people. And yeah, this moving with kids, that was actually very challenging. I remember when my daughter told me after just a few weeks that she wanted to go back home because she didn't understand what any of the other kids said in school. And I started to really doubt my decision. Was it fair to bring 3 kids to the other side of the world and just dump them in a new life with the language that they couldn't understand or anything, just because I wanted to develop my scientific career. But it worked out really well. I actually called my dad and cried, I think, and he told me, you've only been there a few weeks. You have to at least give it some time, try it. I'm sure they will get used to it. And they did. They learned English very fast. They feel proud now, looking back, having lived in a different country, and they still have friends in the US, and they have so many memories from that time, and we have been back a few times to visit as well. So I think even I gave them a gift actually by bringing them to a different country as well. They also got a really nice experience from this. And you can see also that I found some horses also here, or that's a mule actually that I'm riding there. I found a Swedish actually veterinary. She was married to a guy who had sponsored his whole college studies by riding rodeos. That's also a way to do it. All right, and then I'm just going to finish by telling you a little bit quickly about what I do now. So I'm a lecturer, so I teach quite a lot. I still enjoy that very much. I have some lectures and some seminars and case studies, and I do some lab exercises as well with the students. I have a lot of research still. It did not turn out, again, exactly as I had planned. Maybe I had some sort of vision that I would be a PI at some point, but I realized during my postdoc years, I was trying to build a farm for all my animals, which I love also. as you have noticed already. And I had 3 small kids, and it was just too much to do everything at once, but I really wanted to stay in science. So I'm so happy that I've been able to stay working with other PIs so that I did not have to rely on applying for my own money. And that has been possible because of teaching, obviously, because there I get a big part of my salary comes from my teaching work. So that's one way to finance your research as well. And I'm a lot involved in outreach as well. We have these science festivals for young kids, and I go out to schools and teach them about bacteria and microbiology, and that is super fun, I think. And I've always had my kids in the lab. They've been growing up kind of as much in the lab as outside with my courses. All right, so a few words just to finish up. Be curious, be brave, build your network, learn from failure, travel if you have the opportunity, and enjoy the journey. And I still have a lot of animals in my life, and my kids did not get scared off of science, so that's good. Thank you for listening, and please, if you have any questions.
Another round of applause.
Thank you.
Thank you so much, Doc, for your inspiring and honest presentation regarding your journey that you took, from being a student and to where you are today. I think you've reminded us how important people are, because throughout your journey, you've often spoke about relationships that you've managed to create in one or other countries that you've visited, which I think for our students, our researchers, it's very important to maintain those relationships. I often say the academic world is too small, and in one way or the other, you normally have to cross paths with people. You need people. When you have collaborative research, you would need people from different countries. You would have to go to conferences, and there's research that you would need to, get more insight. And this can be possible if you are collaborating with people in other countries and other institutions. And I think also just your journey, it's quite interesting just to show our students to say, don't remain in one country, spread your wings and go to other countries where you would learn also different techniques, you learn several things, and also you'll learn to be independent. I think that actually is quite interesting, and I think they would pick one or two of those and move around with them. So I don't know if there's anyone who would want to ask a question.
I forgot to mention the most important thing, actually. I have a very interesting collaboration with South Africa. So I've been to both Potchefstroom and also to the Venda region, because we're collecting sewage water there together with 2 labs. So I know 2 PhD students from, one from each university really well. They've been twice to visit us in Sweden, and I've been once. And that is also the reason why I got to speak today, because when we had some finishing talks on that collaboration, I met Annelien, and we realized that we both love sheep. So that's also a very fun sort of, social but also science story, I think.
Yeah. Thanks for sharing that. That's quite interesting to hear that you also have existing collaborations that are active here in South Africa. I'm not sure if there's anyone who has a question. It seems everyone is happy, excited about your journey. And I think from my side, thank you for sharing not only your journey, your scientific journey, but also the personal lessons, just to show our colleagues here to say, don't be limited by saying, I've got a family, I've got kids, I won't be able to travel, I won't be able to work in the lab, but let that not be a limiting factor for you, but just continue studying. And also there's lots of opportunities. I like how you gave examples of research that didn't work for over 2 years, but at the end of the day, you managed to get your feet on the ground and start working together with the supportive supervisor. I think most of us can share the same sentiments, with regard to lab work that doesn't really go well, and at the end of the day, it's either you change, you move forward, so that you get your degree. But I think that's sort of encouraging as well. And also the issues of grant application, it doesn't come easy, but you don't need to give up. You just have to continue going for it. But we really, really appreciate you for those encouraging lessons that you've shared. And I think this would help to build and strengthen our students, our researchers, to show that there is light at the end of the tunnel. And somebody always asks, why do we have to put it at the end of the tunnel? But I think there isn't anything that comes easy. But we really appreciate you. And thank you so much. Have a lovely day further.
Thank you. Thanks, you too.
Okay, now we continue. We're starting with presentations. The first person to open the floor is our postdoctoral fellow, Dr. Takalani. She's a postdoc in the Department of Life and Consumer Sciences, and she will be presenting on antioxidant and pro-oxidant effects of green and black tea extracts and ascorbic acid on human sperm function. Over to you, Doc. Thank you. You have 15 minutes. Now my clock will start working. Sorry.
Okay. Good morning, everyone. So, Prof has already read my title, but I'm going to focus more on the green tea for the interest of time, since I only have 15 minutes, but we can engage further as I continue. Okay, so I'm a postdoc here at UNISA, and this study was actually from my PhD, and we are actually advancing from it. Male infertility infertility is a global significant problem that affects thousands of people worldwide. And according to the World Health Organization, infertility is defined as the failure to achieve pregnancy following 12 months of regular unprotected sexual intercourse without the use of contraceptive. And this male infertility can be subdivided into different types, where we have primary infertility, secondary, and unexplained infertility. With primary infertility alluding to a couple that have never achieved pregnancy in their lifetime, and secondary infertility referring to a couple that have in their lifetime achieved pregnancy, but over the years couldn't have biological progenies due to chronic disease or other factor. And some of the causes of infertility are both external and internal factors. But the main culprit for male infertility, which have been discovered, is oxidative stress, which is the imbalance between the level of reactive oxygen species and antioxidant. And this can be seen through the basic semen analysis, where we'll have 3 cases: oligospermia, where there is a few sperm less than 15 million per mil, and we'll have astenospermia, where the motility is significantly low, and teratospermia, which is characterized by poor morphology. Just as oxidative stress is damaging, there is also a term which we often disregard, which is known as reductive stress, which is the mirror of oxidative stress, where the number of antioxidants are actually higher than the oxidant. And as you can see here, I've tried to sort of give you a visual simulation of a sperm that had a damaged morphology, and we had a few sperm. So this is a combination of all those 3 abnormalities which I showed on the previous slide. But here is where we have a redox balance, where we have a balance between the level of antioxidant and reactive oxygen species. Currently, there have been a novel which was proposed by Agarwal, who is referred to as the father of andrology. And this novel measures oxidative stress within the semen sample, because most of the basic semen sample do not measure oxidative stress within the sample, which is a crucial marker in determining the infertility in a male. So this is just how the procedure go. We have the indicators, and there is a myoxis which I use in this study to actually measure the rate of oxidative stress within the sample, which I will show you the procedure as we go on the methodology. And the study plant which we use is your everyday green tea that you drink every morning or in the afternoon. Green tea has been reported to have several antioxidants which can combat the damaging effect of oxidative stress. And it is said to enhance seminal parameters such as your sperm motility, the acrosome reaction, sperm vitality, morphology, as well as counteracting DNA fragmentation. So as I've already mentioned, that the current semen analysis falls short of the measurement of oxidative stress, a crucial marker to determine the antioxidant targeted to actually counteract the rate of oxidative stress. And this has become a problem because although many studies are actually using this antioxidant or medicinal plants, they do not go back to measure either reductive stress or the oxidative stress within the semen sample, which is leaving many men to be undiagnosed and not to have a targeted treatment towards their male infertility. The aim of this study was to evaluate the antioxidant activity of green tea aqueous extract on normozoospermic cell, which is your sperm that had a percentage of 80% motility under oxidative stress induced by cumin hydroperoxide. And our objective was to measure the protective effect of green tea aqueous extract on human sperm parameters. This was done for 60 and 120 minutes at 37 degrees. The parameter that we measured at 120 minutes was sperm motility and vitality, and the ones that we measured for 60 minutes was the oxidation reduction potential, the mitochondria membrane potential, the DNA fragmentation, and the acrosome reaction. And the second objective was to determine the oxidation reduction potential on normozoospermic sample after the treatment of the green tea, which is the antioxidant counteracting the oxidative stress, and ascorbic acid, which was used as a comparative using the myoxis, which is the novel that we use to measure this oxidative stress. And lastly, was to compare the antioxidant effect of green tea against ascorbic acid with all those parameters that I've mentioned. So this study was fortunate enough that we were able to calibrate the concentration to induce the oxidative stress, which was cumin hydroperoxide, mimicking the environment of oxidative stress. So if you would like to have a read, you can go and check out our publication, which will give you insight as to how we calibrate the concentration we use to induce oxidative stress, as well as the concentration that gave the maximum effect for motility using the EC50 for ascorbic acid. And this is just an outline of how we came about the concentration of our plant. And we were looking at a study that showed that a human can consume a total of 6 cups per day of green tea. This is the outline of the methodology. So just to maybe save time, I'm going to sort of give a highlight, and if you have questions, you can ask me after the presentation. So this study actually did receive ethics, and we recruited donors that were about 18 to 45 years old, and we screened them using the sperm class analyzer, where they voluntarily donated their semen sample, and then we matched it against the World Health Organization criteria for sperm which is more than 15 million per mil and having a motility of at least 40%. And thereafter, because we wanted highly motile sperm, since we are subjecting it to oxidative stress, we used the double density gradient, 80 and 40, and then those are the parameters that we measured, as well as the assays that we use in the microscope. So cumin hydroperoxide acted as our positive control. And then we had the ascorbic acid as well as the green tea. Our negative control was the human tubular fluid, which mimics the environment of the human fluid. So this is just one of the parameters that we measured, which is the kinematic parameter, also known as the motion parameter, on how the sperm is going to move. So as you can see, all this kinematic parameter increased, statistically increased when we compared it to the positive control for both green tea and ascorbic acid. But green tea showed positive results when we were comparing it to ascorbic acid, showing that this antioxidant is capable for enhancing the seminal parameter. And interestingly, when we look at the oxidation reduction potential with relative to ROS, which is the main culprit for causing male infertility and damaging the seminal parameter, it actually decreased. The percentage of ROS positive sperm actually decreased, which shows that indeed the plant was able to counteract the induced oxidative stress. This is just a picture of how the sperm look under the fluorescent microscope, where the red one is indicating that there is ROS positive, and the light green, or sometimes it doesn't fluorescent, is showing that there is no ROS. So this is just a summary as well of how the results look like. As you can see, the oxidation reduction potential after being measured by the myoxis actually decreased. And the SORP, which is the same as the ORP, but it is after we have normalized the value that we receive from the ORP with the sperm concentration. And then we also have the intracellular ROS, which also decrease. So this decrease in relative to the positive control, and the same was notable for ascorbic acid. So when we compare our green tea with ascorbic acid, we can actually see that the antioxidant which are said to actually enhance, our plant is actually doing the same, showing that it can be a therapeutic agent for treating male infertility. And then we also have our total motility, progressive motility, and the sperm viability. Sperm motility is very important because if the sperm is unable to swim, it has low progressive motility, there won't be any fertilization taking place. So this was done at 60 and 120 minutes. So as you can see here, we have the total motility, which is comprising of the progressive motile sperm, the non-progressive motile sperm, as well as those that are actually dead. So we calculated according to the percentage. So when we compare this to our positive control, we can see that our extract was able to improve the motility as well as the progressive motility on some concentrations, which I will show as I finalize the results, as well as in vitality, showing that our plants can confer the cytoprotective effect on the sperm. And finally, we have our the mitochondria membrane potential, which it houses is the powerhouse of a sperm in order for the sperm to swim, because it comprises of the ATP, which is your adenosine triphosphate. So this was increasing, and the acrosome reaction actually increased, because in order for the sperm to actually fertilize, it needs to release a hormone called acrosin to destroy the zona pellucida. So this actually increased, and DNA fragmentation, which is the damage of the sperm DNA, actually decreased, showing that there is a correlation. If we look back at ROS, which actually decreased, we also had a decrease in DNA fragmentation, showing that our plant is able to counteract that damaging effect, which could have caused DNA fragmentation. The oxidative stress could have caused DNA fragmentation, but our plant was able to counteract it, reducing ROS and actually reducing the DNA fragmentation, and thereby increasing the acrosome reaction and the intact MMMP. So as you can see here, this is just an example of how the intact DNA would look like. It will fluorescent green, and the damaged DNA would fluorescent orange. And then in terms of the acrosome reacted sperm, you will see a fluorescent at the equatorial region of the sperm head. And when we look at the intact MMMP, the intact MMMP is going to fluorescent orange at the neck region of the sperm. And then if it is not intact, it is rather disrupted, then it will not fluorescent, or it will fluorescent green, depending on the dye or the assay that you're following. And finally, our green tea was able to confer the antioxidant potential in relative to ascorbic acid. And just to give our future recommendations and future study, currently I'm actually furthering this study by looking at the in vivo study and trying out other assays and trying to isolate the bioactive compounds which are in green tea as well as in mbesu. So I would just like to appreciate the principal investigators that were involved, and this study also attracted a lot of funders during this study. I thank you.
Thank you so much. Thank you so much for the interesting study. In simple language, for those who don't understand your ROS and so on, what advice can you give to people if they are thinking, oh, I have the same problem? Do we need to drink more green tea? Or what foods do we have to eat and vegetables so that we can get more ascorbic acid?
Okay. While this remains a sensitive topic, I would advise males and not female, because I'm more into males studies. So if you are maybe trying, I would advise that the first step is to go for a basic semen analysis, where they will give you a brief overview of how your semen is. The most important ones would be if your sperm is swimming, if there is morphological defect, or if your sperm is not vital. And thereafter, you must also maybe measure the rate of oxidative stress. This study has actually attracted a lot of studies that are now venturing into using the myoxis to measure and also map it against the World Health Organization standard. That's wherein you can start now reading articles and maybe trying out green tea. We also had black tea, we also had rooibos, all the variants of Camellia sinensis and Aspalathus cinearis. And I would also advise that it is very important to be cognizant of the dosage, because if you take more dose, then you will actually be opening up for the reductive stress, which is going to mirror oxidative stress and damage. So a human is said to at least consume 6 cups of green tea per day. It is still very much okay for you as a man to drink. Over time, I believe your semen parameters will improve, and then you go back again and see if they have improved. Thank you.
And let's also think about the economic status. When you have more, it means more money. When you have more kids. Okay, let me open 2 questions, 2 or 3 questions, then we can proceed.
Okay, thank you so much for such an interesting study. I'm just curious here because things that affect sperm quality, we have long-term factors and short-term factors. So I want to understand from your study, from your understanding of this, the work that you're doing, is the green tea a long-term solution, or is sperm it's just there for a short period of time?
Okay, that's a very interesting question. It's just like taking your medication. Maybe, let's say when you have flu, it's not going to be for a long time period because you're still going to get the flu. So when, if I'm answering your question, it's for a short term, because for an example, we expose this sperm cells to oxidative stress for a certain period of time. And then we incubated those sperm cells with green tea for a certain period of time. And thereafter, that's when we get the results. But if the patient or the donor now goes back and starts smoking, smoking also affects your sperm. Drinking also affects your sperm. Exposure to environmental toxicant also affect your sperm. And also chronic disease, if you develop maybe obesity, for example, or whichever chronic disease is interrelated with male infertility. So you're still going to need to go back now to the basic semen analysis measure and then counteract, and then you will see the results after a long period of time. It also depends on the variants or on the genetic makeup of an individual. The extract may react to you and may not react to another person, and based also on the dosage that you are taking. Hence, we had different dosage that we were testing. Yeah.
And maybe that's why you still need to go the in vivo way,
yes,
and also clinical trials if possible. I think there's one hand at the back. Yes.
No, thank you so much for the opportunities. My name is Richard. I'm more interested actually in human because I'm specializing in animal reproduction. I just wanted to find out if maybe you consider also the method of the collection. If I'm not mistaken, since you say that the semen they donated, did you consider also the method for the collection? Because I think it also affects the mortalities.
The method of what?
of the semen collection. And then the second one, I just wanted to find out from you, how much average percentage for the sperm to fertilize, the percentage that actually acceptable percentage motilities to be fertilized. Thank you.
Okay, so in terms of the method of collection, we wouldn't have gotten these results if we were not cognizant of how we are handling the sperm. If you remember, the sperm is a very sensitive cell. So when we are collecting the sperm, the first thing that we do, we make sure that our donors are aware of the process, and then we designated a specific room. I'm going to be a bit sensitive now. We designated a specific room for the semen donation where the donors, the participant, after they had agreed, they went to the room, and then, which was closer to our lab, not even 1 minute away, just there. And then they did what they were doing. We gave them a vial or a cup, and then immediately they brought the sperm, and then we incubated for 37 degrees to allow liquefaction, because if we leave it there, it's going to die, because sperm die with temperature. The colder it becomes, there is more death. But if we maintain it at 37 degrees, then it's going to remain alive, which is why the sperm is also housed within the scrotum in that specific area. And then your next question was in terms of how much percentage. If you recall, I mentioned that according to the World Health Organization. So the World Health Organization has a specific criteria or a benchmark where the sperm must at least be 15 million per mil, and then the motility must be at least 40%. Less than that, chances of fertilization might not occur, because sperm dies within a second. As soon as the sperm is outside in the open environment, it starts to die, looking at the lab environment. And also if we look at the human reproduction itself, as soon as the sperm is released into the female reproductive organ, there are so many factors that hinders the sperm from reaching the oocyte in order for fertilization to occur.
Thank you. Okay, thank you so much. I think for those who have further questions, you can engage with Dr. T during, there were two actually. So that's why I'm saying they can engage with her during tea break. Will that be fine in the interest of time? So thank you so much for setting the tone for today's presentations. So I hope the students and the other researchers that are coming will try to benchmark using the level that she set for us. Thank you for your interesting work, and we hope that very promising results will come out of your research so that you can help people in need. Thank you, Doc.
Thank you.
So the next presenter, we have a message from one of the sponsors, Ingaba Biotech. Will that be Pule? Okay, over to you, and thank you.
Good morning, colleagues. It becomes quite tough to come and stand here after such a great presentation. So I'm going to come here as well and do what I have to do, and I will leave. So this is just a quick message from Ingaba Biotech. We do have an exhibition stand outside So to all of the attendees or the delegates who wish to talk to myself relating to the work we do at Inqaba Biotech, you can visit us outside. And again, I wish I could have donated my time to the presenter that was there before, because I think the work that she was presenting on is work that most of us are interested in. I will be having my 6 cups of green tea from now on. So just quickly, I'm excited by the fact that most faces I see here are people who already have interacted with Inqaba before, but just for the benefit of those who have not, I'm going to quickly sprint through my 72-slide presentation, and hopefully I can make it in 15 minutes. So I start now. So Inqaba, I have that already on. So this is just a brief timeline of the development of the company I come from. And the exciting part about me is that I'm Nguni, so when I say the name of the company, it fills up this whole room. I'm just going to say Inqaba Biotech. You heard that, yeah? So it fills up the whole. So this is the timeline of how the company has developed in the years, starting from solving a solution, or rather solving a problem. We can't solve solutions. Solving a problem of primers in the country. So when the company started, one of the co-founders was struggling to get primers to perform PCR. So they started with a collective and some funders, and they synthesized primers locally. And since 2002, when the company started, we still are the only company in the sub-Saharan Africa that synthesizes primers locally. There are some competing suppliers, but in most cases they import their primers. This gives advantage to the end users because we have quick turnaround time and technical support that is readily available. And also, maybe just for others, this is a marketing talk. This is just a message. So I'm not going to be presenting as it has been done previously, nice graphs of how sales have been and how sales have not been. So this is purely a marketing presentation. And in the years, we have managed to open subsidiaries in East and West Africa. The first one was done in Nairobi, Kenya, and we have increased our footprint there as well, opening offices in Tanzania as well. I'm sorry that's not showing there. Oh yeah, it shows in 2019. And also in 2015, we opened a subsidiary in West Africa. This was in Ibadan, Nigeria. And the company has grown from strength to strength since. We are based in Pretoria, and that is one of the buildings that we occupy in Pretoria. And I always mention this because this is a historical building. In the area that we are situated in, it's called Makelniek. So that building is over 100 years old, and it was the first building that was actually first structure that was built in the area that we occupy. That striped orange building is where most of our admin work is done, and the one with the big billboard is where some of our labs are. The types of services or solutions that we have at Inqaba Biotech include, as mentioned before, oligosynthesis, where we synthesize primers locally, and we have labs and technical staff that assist in the synthesis of such. And we do have sequencing platforms, both Sanger and next-generation sequencing. Now, the interesting about our next-generation sequencing thing is, in fact, a few interesting points here, is that we have support in terms of data analysis. We have bioinformaticians in-house that could assist, or that can assist you in analyzing your data. And the good report is we have had some positive feedback from researchers here on campus that have used our facility. And what has evolved from the next generation sequencing service is a partnership between UNISA and Inqaba Biotech, where we co-own an instrument that has been used in one of Africa's or sub-Saharan Africa's biggest projects, which is called the Africa BP. This is where local, or rather indigenous plants and animal samples are sequenced and the data kept locally. What the company identified is that in most cases, when we have big projects, the samples are sent abroad. So we're thinking, how do we trap samples in Africa? And samples for Africa get sequenced in Africa. And that when the partnership between Inqaba and UNISA was formed, where we co-owned that instrument you see up there, it's called the PacBio, it's for next generation sequencing, and that is where the Africa Bio project rather is being sequenced. All the genomes are sequenced on that instrument. And there are quite a few advantages for using that instrument because it has complete whole genome sequencing. It also has targeted sequencing. We do complete transcriptomes and epigenomes. And moving on from that, we also are distributing. Now, Inqaba is a two-armed company. One is where we do our give services to end users or researchers, and the other one is a distribution arm where we give, we supply end users with support or reagents that they need in the lab. These include products that could be found from these brands that are displayed, including NEB, or rather New England Biolabs, Eppendorf, Zymo, Clinton, just to name a few. And from some of these brands, these are the solutions that we get. From the Zymo brand, we have extraction solutions. We can extract from all sample types. If you're looking to extract DNA or RNA, we have solutions for you. And if you want to downstream that into PCR, we also have solutions where if researchers are looking to do just PCR or are looking to do library prep for whole genome sequencing, we have solutions from a brand called New England Biolabs, again, which has shown great success from researchers who are currently using it. And beyond the reagents, we also are a distributor of of instruments. And we are a proud distributor of a global leader, which is Eppendorf. So Eppendorf as well, they have consumables, which are your tips and tubes. And we also do equipment, your fridges, your freezers, PCR machines, centrifuges, and if there are some researchers who are looking to automate their work, then we also have robots from Eppendorf that we can personalize or rather that we can tailor for your workflow. And as well, we have one of our newest baby, which is BioReba. This also appeals to plant biologists or pathologists. This have solutions for sample collection if you want to do any diagnostic works on any type of plant that you're looking for. We have some agri-strips that we supply from the brand called BioReba. And now you may ask yourself, why choose Inqaba Biotech? So I'm seeing friendly stuff. I don't know why I put that in there because our finance team is not the friendliest. Some have experience with our finance team, but amongst our team that does customer visit, we have a friendly staff, like this face that's standing in front of you right now. Very friendly face, very friendly staff. And you can maybe experience this friendliness when you come and visit our stand. Also, we also do demo placement. If there are any researchers who are maybe uncertain of any instrument that they like to buy, we do demo placement where we can place the instrument in your lab, give training, and then leave it to you for a week or so. Then if you are satisfied on that, then we can maybe proceed to the next steps. And again, this is, I like putting the slide out, is that we heard you. So again, with the effort of empowering science in Africa, Inqaba Biotech have secured a big project, which is to manufacture consumables locally. For now, we'll start by manufacturing tips, which will be the 200 mils and the 200 microliter and 1,000 microliter filtered and unfiltered tips. And we will be the only company that is manufacturing these locally. So this will also cut from cost, it will also cut from ETAs. And I put the next slide as a test. So if the next slide you cannot see it properly, it means to those who are wearing glasses, it means you have to go change your prescription. To those who don't wear glasses, it means you have to start wearing them. So if that is blurry to you, then come see me for consultation. Now, thank you so much, colleagues. I appreciate your time.
Thank you so much for sharing with us what you guys offer at Inaba. I mean, for some of us, we've been working with you guys for quite a long time, but I'm not sure if there's anyone who has a question, maybe just one or two. Otherwise, if you're shy to ask a question now, you can go to their stand outside, and then you can ask those questions. If you don't want us to hear what you want to ask, I think there's a question at the back there. Was that a hand? Oh, okay. All right. Thank you so much. We really appreciate. So the time now is 10:46, and I think maybe we can just take those 15 minutes, grab some tea, and then quickly come back so that we can start with our second session.
Side. Hey, I must smile for the photos. All right, so welcome back. I'm Annalene Malotsi. I'll be the chair for the second session this morning. So we will just continue the momentum from the first session. So just a reminder of our house rules to please put your phone on silent, and then also for the presenters, you each have 15 minutes to present and then a few minutes for questions. So I'm going to start us right off with our first presenter, which is Mr. Fulufelo Mudau. So you are up to present. So the title for Mr. Mudau's topic, while he is still coming up, it's breed-specific effects of gallium supplementation on fly infestation and growth performance in Nguni and Simmentaler cattle.
Yes.
Okay, thank you, Chair. Machironi, good morning, everyone. There we go. Thank you, Chair, and good morning to everyone. My name is Fulufelo Mudau. I'm a PhD student at Stellenbosch University, and I'll be sharing with you today some of my findings from my PhD work. I'm doing this study under the supervision of Dr. Annalene Malotsi, co-supervised by Dr. Obio Durana. So this presentation is about the breed effects of gallium, which is a garlic-based product from Allied Nutrition. So I want to check its effects on supplementation on fly infestation and growth parameters in Nguni and Simmentaler cattle. Flies. So flies are a persistent challenge in livestock production. They reduce the weight gain by disrupting cattle feeding. So the cattle try to defend themselves from flies by doing some defensive behaviors, which then make them lose time of feeding, and that affect the weight gain. So traditionally and currently, farmers still rely on chemical control to deal with the issue of fly infestation. However, there's always been challenges with fly resistance towards the chemicals that are being used. So there's a need for sustainable natural alternatives to combat the issue of flies in livestock. Such solutions include the use of garlic feed-based additives to repel flies. However, currently there's limited information on the field trials as to as to the effectiveness of using garlic and garlic-based additives to repel flies. It is also unclear whether the cattle respond the same to the garlic supplementation when it comes to production traits and fly infestation. Hence, there's a need to evaluate the gallium supplementation on both fly infestation and growth performance in Nguni and Simmentaler cattle, using Nguni as the indigenous breed and exotic breed as Simmentaler cattle. So this study was conducted at Stellenbosch University Farm, Mariendal Experimental Farm, where we got the ethics approval from the ethics committee at Stellenbosch University, and those are the compositions of the gallium. So I'll refer to it now as gallium. So it's composed of garlic oil, garlic powder, and allyl disulfide, which equates to 36.5% of the product, and the rest was sodium chloride. So it comes as a homogeneous particles, and it is registered with the Department of Agriculture in South Africa based on the Act 36 of 1947. We used 30 natural infested heifers, of which we had 16 goonies, and I divided those into two. 8 were allocated to the gallium treatment, and 8 were under control supplementation. And then we had 14 cementalers, where 7 was in control and 7 was in the gallium. So the gallium was supplemented at 5 grams per head per day. And the trial ran for a period of 43 days in a completely randomized design. So during the experiment, we measured both fly counts and the growth performance, which included dry matter intake, average daily gain, feed conversion ratio, as well as the final weight gain. And to measure the fly counts, I used the digital camera, where I took pictures of the animals infested with flies and had to go down and count flies from those digital pictures. And for analysis, I used the analysis of covariance as for growth performance, and generalized additive mixed model for the fly counts. So moving on to what we have discovered from the study is that when we look at the feed intake, the product gallium did not really have a significant effect on the feed intake. So if we look at the first chart A, it demonstrates us that there's no significant difference between the treatment in both breeds. So moving on to the average daily gain, we discovered that the cementalers had higher average daily gain than Nguni, and we still didn't see any significant effect of diet. So that means the gallium did not improve or decrease the average daily gain in both breeds. And then we also noticed that there were small changes in the final body weight. So with the cementalers having a higher body weight gain, which could also be associated to breed rather than the diet effect. So that showed us that the gallium didn't reduce the palatability of the feed. And what I can say from these results is that, so if we look at the Nguni, it had so when we look at the Nguni, and the gallium had less intake, whereas at the cementala it had more daily intake. So I'll move on to the differences in fly infestation. So this is where it was more interesting as well, because we saw a large difference in fly burden caused by breed. So this shows us that the gallium didn't have much effect on the fly repellents. However, it was the significant difference that we see there between the breeds was based on the genetic composition of the breeds. And also, we can see that the cementala had substantially high fly counts compared to the Nguni, and as we know from the reports that from the previous studies, that Ngunis have been associated with resistance to ectoparasites. So looking at both the Nguni and cementala, the gallium did not have significant differences or didn't significantly reduce the fly infestation. However, when we look at the Ngunis, the gallium had a slightly positive impact on the fly resistance, with the gallium showing less fly infestation compared to the control. And now looking at the infestation fluctuations throughout the study, we can see that both breeds, Nguni maintained less fly infestation under the gallium treatment, as well as and we see that the breed difference was consistently the same throughout the breeds when we look at the cementala and the Nguni infestation, with Nguni showing less infestation compared to cementala. And this tells us that the supplementation of gallium had no temporal effect on Cementela rather, but we can see some effects on the Nguni infestation. So this tells us that maybe the organosulfur compounds in the gallium are also affected by, their effectiveness is also affected by the breed composition or genetic makeup of breed. So in conclusion, we see that the primary driver of the productivity and resistance was based on breed rather than the gallium or the dietary effect. So with Nguni showing markedly lower fly burdens, which indicate natural resistance, as it has been proven by other studies that Ngunis are resistant to ectoparasites. Gallium also had modest breed-dependent effect on performance and fly infestation. As we saw on Ngunis, there were less flies on Ngunis, whereas it didn't have effect on Cementelas. And in general, this tells us that combining resistance with nutritional interventions such as gallium may provide a sustainable approach for fly and improved cackle health. And now, with these results that we have found, I can recommend that future studies should look at the biological mechanisms underlying the Nguni fly resistance to support breeding for enhanced fly burden resistance. So that means there is more to it than only feeding the gallium. So we need to look at the nutrigenomic part of it and see if there are certain pathways or genes that Ngunis are activating, that gallium is activating in Ngunis that are improving the resistance to these particular flies, and also see what happens to the Cementalas when we give them the gallium, if it's either rather suppressing the genes that are supposed to be responsible for fly resistance. I would like to acknowledge these institutions and for funding the project as well as participating in the trials.
All right, thank you so much, Fulufelo, for an interesting presentation. Do we have any questions from the floor? Yes.
Okay, thank you so much for such an interesting study, Fulufelo. Just observed something. You mentioned that infestation might be breed specific of flies, right? But if you look at the characteristics of the two breeds that you are comparing, especially the coat characteristics, like they have different coat colors, coat pattern. Don't you think that can play a role in the fly's preference where they go to these animals?
Can I answer?
Yeah, you can.
Okay, thank you for that. That's a very good question. So the coat color actually does play a factor in fly infestation, because I read a study where they found that there's a certain gene that plays a role in attracting on the coat color, KIT gene. So what we did, we tried by all means to normalize the coat color. So we had the animals of the same color, or coat color. So when it comes to the coat color, the hair characteristics of the coat dents, that was not really an issue because it doesn't occlude us from seeing the infestation, but the coat color does. So we try to have the animals of the same coat color so that we can take away that confounding factor. I don't know if I answered your question. I can.
Okay, that one we can clarify later. But anyway, for another one, I wanted to ask about the issue of the number of the animals. for what the conclusion that you have.
Yes.
It's a strong claim, and I'm looking at the number of the animals that you have. Do you think that's viable?
Yes, because it was, so we did the counts on weekly, so it was not only taken once. Pardon?
I mean, you had 8 animals.
Yes, I did a power analysis, and it was enough for this particular.
No, it's fine.
Yes.
Any other questions? Ray? Ndabe, Ray?
Thank you very much for your presentation. I just had a question regarding the flies themselves. So did you perhaps look into the specific species of flies, or do you think that that would be a useful thing to consider based on if there's maybe a specific species that is attracted to these animals?
Yes, that's correct. So I did look at the fly species, and we found that most of them, they were stable flies. We had a little bit of house flies, but it was mostly stable flies that we identified from the trial.
Okay, any other questions? Ray, are you happy with the answer? No more questions, all right. Thank you, Fulu.
Thank you.
All right, now my computer's over here. Our next speaker is MP Nam. Is MP Nam? Yeah. Great. You'll have to give us your full name. Okay, you will share that with us. So she will be presenting on antibacterial activity of secondary metabolites from endophytes associated with Phenoculum vulgar. I think you'll have to pronounce those ones for us. All right.
Good morning, everyone. Nature has proven to be the best chemist so far. While synthetic laboratories spend lots of years and a lot of money to produce novel substances every time, endophytes do this quietly inside plant tissue every day. My name is Moge Patience, and today I will be presenting on the topic antibacterial activity of secondary metabolite of endophyte associated with Phenoculum vulgare and Venunia amygdalina under the supervision of Professor Masebek Tracy and Dr. Mameja Neo. I'm a master's student. Here is our presentation outline from the background right down to the references. Globally, about 40% of total population is affected with gastrointestinal disorder, and this is often caused by infectious agents such as bacteria and parasites or lifestyle factors such as stress and diet. Gastrointestinal disorder, the pathogens that are often involved include Helicobacter pylori, which often associated with gastritis, peptic ulcer, and sometimes may lead to gastric cancer, and E. coli, which is Escherichia coli, which is often associated with diarrhea. The eradication of this microorganism has become increasingly difficult because of the emergence of antibiotic resistant strands, and this has consequently prompted for alternative therapy from medicinal plants such as Phenoculum vulgare and Venunia amygdalina. This plant hosts a variety of microorganisms, often known as endophytes, which live in a mutualistic relationship with these plants and often produce secondary metabolites. This takes us to the aim of our study, which is to evaluate the antibacterial activity of secondary metabolites from endophyte associated with Feniculum vulgare and Venunia amygdalina against H. pylori and E. coli. Here are the specific objectives of our study. The first is to isolate and identify culturable endophytes, followed by the identification of this endophyte. The third objective will be to extract secondary metabolite from this endophyte and determine the antibacterial activity of the crude extract on H. pylori and E. coli, as well as anti-inflammatory assay on the raw macrophages. The last objective will be to determine if our crude extract is safe or not. So here is our plan of interest. So for someone, since we are talking about practical, some of you who have never seen bitter leaf before, this is Venunia amygdalina. It is called bitter leaf. As its name says, it's very bitter. So I am from Cameroon, and we use this in order to prepare egusi soup. We use it as well to prepare groundnut soup. And in my language, it is called kuri, which is the first name. The other names I won't pronounce because I don't want to make any mistakes. Thank you. Our next plant is Feniculum vulgare, commonly known as fennel, and it's mostly used in our kitchens, as a spice. It's also used, I think, it's also a common ingredient in. There is this substance which we drink, especially we give to kids when they have colic. So grip water, that's the name I was looking for. So it is one of the ingredients of grip water, meaning it's very important for gastrointestinal problems, as well as the bitter leaf. So if you see this leaf and you're having stomach issue, you can just as well just squeeze them in a cup of water and have it to drink so that your stomach can cool. So because of this, it takes us to our problem statement. So H. pylori and E. coli has become a public health concern, and this is because of the ineffectiveness of the current treatment therapy. And as a result, we are moving back to nature, as I mentioned earlier, which is the use of this plants and Feniculum vulgare. Unfortunately, I was not able to get that one. So, but for this study, we will not focus on the plant extracts due to conservation. We will rather focus on the endophyte isolated from this plant. So here, it's a broad overview of what we will be doing for our study. We will start with the isolation and identification of our culturable endophytes. Then we will extract our secondary metabolites. We will move on to perform several assays, which will be the MIC, anti-inflammatory, as well as the cytotoxicity assay. So here is a breakdown of what we will be doing for the identification. So in order to get the endophyte from this plant, we will begin by harvesting healthy leaves, the stems and roots of the plants, which we will surface sterilize with sodium hypochlorite followed with ethanol and distilled water. We will culture them and get a mixed population, which we will reculture in order to obtain pure isolates, where we will perform both molecular and morphological techniques. So, as mentioned earlier, we will continue with the extraction of our secondary metabolites using solvent extraction ethyl acetate, where from the identify endophytes, we will proceed with fermentation and extracts using ethyl acetate, and we obtain our crude extract. With the crude extract, we will start performing the minimum inhibitory concentration, which is simply the simplest, the concentration, the least concentration at which we will not observe the growth of microorganisms any longer. The next slides, we will perform anti-inflammatory assay, and we will be using the raw macrophage, and with this, we will as well obtain pro-inflammatory, some pro-inflammatory molecules such as the interleukins 1 and 6. And here we will just be observing, and using the ELISA technique, we will see if our crude extracts will be able to promote or reduce this pro-inflammatory assay, given that gastritis, when you get gastritis, sometimes it's because of this inflammation in the system. And the next slides, we are going to talk about the cytotoxicity assay, as mentioned before, where we will be seeding our cells in using the MTT assay to observe if the cells will still be alive or they will be dead, or to see if our crude extract is indeed safe or not safe for us to use. Our expected outcome, so we think of the positive, we are positive, so we expect that at the end of this study, we will obtain secondary metabolite from this endophyte, and they may perhaps have antibacterial activity against H. pylori and E. coli, and we also expect that the crude extract may have potential to exhibit minimal toxicity. That is, we expect that our crude extract would not be toxic. So here are our references. Thank you so much for listening. So in conclusion, while I was reflecting on my topic and the theme and, being in the university, I kept on asking myself, when we get all this information, when we gather all this information as researchers, for example, let's say I'm doing master's and I'm not sure if I'm coming back here maybe to do PhD. So when we get this information, we do attend this symposium year after year. When we get this information, what do we eventually do with this information? Or when we finish our academics, and keep this information, what do we do with the result that we obtain? What do we do next? Do we just focus? Because there is a problem, which is antibiotic resistance. There is a problem at hand. And in an African context, bringing it down to UNISA, what is it that we can do in order to bring a solution to what is actually happening? So in as much as we present, in as much as we do what we are doing, but the final say is, can we take all this result and, make it so become something tangible, like the common say, what is it that we bring to the table as the symposium goes on year after year? What do we do with the knowledge we gather, the presentation we observe year after year? Thank you so much. I will not stop without thanking my supervisors for always guiding me, midnight, Sundays, Saturdays. We are always there. Thank you, Prof. Masebe Tracy, and thank you so much, Dr. Mameja, for your support every day and every time. Thank you.
Thank you so much, Muge. Thank you for a wonderful presentation. And I hope we'll see you with the results next time at the symposium, or maybe even before that. right? Do we have any questions? There's one question.
Thank you for your presentation. I just want clarity. Also, you were presenting your proposal.
Yes, ma'am.
Okay. Thank you. I just wanted clarity on that because I was expecting results and, going further. But yeah, thank you.
Any other questions? Yes, Mtabi.
Hi, thank you for your presentation. I saw on you say you're going to be doing extraction. You included all the parts of a plant except the flowers. Why not the flowers?
I didn't include the flowers because from literature, I wouldn't say why I didn't include the flowers. I was just interested about the leaves because personally I used to use it back home, and those are the parts that we mostly use. But as you mentioned, people do use flowers. So I thought perhaps since I'm working with endophytes, I might easily get them from the leaf, from the stem, and as well as from the roots. But I may also take flowers into consideration. Thank you so much.
All right, thank you. Any other questions? When are you expecting to start with your actual trial?
I started last week with my culture media. Yes. So currently, after this, perhaps I will be going to the lab.
All right. Okay. Thank you so much, Muge.
Muge.
All right.
Thank you.
Thank you. We can give her a hand of applause. All right. So our next speaker is Makalepeto. Am I saying that right? Makalepeto. Are you here with us? No, not online. Makalepeto, do you have a presentation for Makalapeto? Yeah. Nope. I'm butchering their name. Anyhow, okay. So if Makalapeto is not here, we will then move on to the next speaker, which is Matloa. D. Matloa. Is D. Matloa not here? We are looking for D. Matloa. Not yet today. Okay, then we have to go to the next one. It looks like we're having a very short session before lunch, right? Is she online? Okay, will she present now online? Oh, the next one. K. Twala, yes. So our next presentation will then be an online presentation by K. Twala, and it's on the expression, purification, and characterization of fluorinase from Streptomyces, Moracansis, and a lot of other bacteria. So can we have K. Twala online?
I'm just having trouble sharing my presentation. Just wait for it. I think I'm only able to share my screen. Is it visible to everyone? Hello? Is my presentation visible?
Yes, your presentation is visible. You can just put it in presenter mode, and then you can also share your video with us so we can see you.
Oh, okay. So I have to go. And there we go. Hello.
We can see you, but we see many screens now. There we go.
I'm just going to fix that. Is that okay?
Yes, perfect.
All right. Good morning, ladies and gentlemen. My name is Kanisile Twala, and this is my master's research titled The Expression, Purification, and Characterization of a Fluorinase from Streptomyces chlorokensis and Micromonospora terracosensis and Peptococci bacterium CEP3. Mouthful, I know. So essentially what has brought me to this research is the rise of fluorinated compounds in the pharmaceutical industry, the agricultural industry, and the material sciences industry. It is so successful, it is so commercially successful to add a fluorine moiety to an already existing organic or chemical compound because it has better effects, it has higher bioavailability when ingested, and it has a stronger binding affinity to its targets. Right, so in the image you will see on your screen, that is just a list, well, some chemical structures of some of the blockbuster drugs, so they're called. That is a term coined in the States because these drugs made about $100 million in profit once they hit the markets, therefore coining the term blockbuster drugs. Right, so not only are they effective, but they are also commercially viable, highly commercially viable, and therefore more and more interest is being drawn into just incorporating a fluorine moiety to already existing drugs and interventions. Right, so now the issue with that is that now fluorine incorporation is always done through chemical synthesis. Because of the electronegativity of the fluoride ion, fluorination is somewhat difficult, and therefore it needs very stringent conditions and very harsh conditions, and it does not adhere to any atomic economy of any sorts. So the reagents are volatile. Even though in industry it is still being improved step by step, chemical fluorination is seen as very harmful to the environment. However, it's almost like it's a necessary evil because of the demand that comes from the need for fluorinated drugs and other compounds. Now, there's not many alternative methods to fluorination, but biocatalysts are seeming to be a very viable way for us to continue, or just basically have the best of both worlds, continuing to produce better quality and more effective agrochemicals and pharmaceuticals, while also still respecting our environment. Now, the issue with that is that although fluorine is about, I think, the 13th most abundant element in the Earth's crust, it is very difficult to isolate, it is very difficult to incorporate, because fluorine often reacts with every single compound around it, so it's usually in a very locked form. Ergo why chemical fluorination was always seen or is used industrially. Through mimicking nature or just looking at nature, scientists over the years, from about 1963, have seen that there are some plants and bacteria that are able to metabolize fluorine. They're able to catalyze or make secondary metabolites that contain a fluorine atom. Some of the plants use this, for example, gifblaar, as it is known in Southern Africa. It creates fluoroacetate within itself as a defense mechanism against being eaten by predators. Now, through seeing this, we understand that nature has somehow evolved in order to use fluorine. Is evolving a mechanism in order to use fluorine and incorporate it into its own organic molecules without causing fluorine toxicity or ergo killing the plant or the bacterial host. It has been very difficult to isolate this from plants, so the mechanism in plants has yet to be elucidated. However, in bacteria, it has been found, and what has been found is the enzyme called a fluorinase. It is currently the only enzyme that is able to catalyze a carbon-fluorine bond. And therefore, it is a sort of bearing into understanding and industrially adapting biocatalysts for fluorination purposes. So far, there are about less than 15 fluorinases that have been identified, and only 2 that have their complete structure and imaging created. And because of that, we use sequence alignment and blast searches in order to find and discover more fluorinating enzyme sequences within other bacterial species and strains. Now, my research objective is to optimize the expression, denaturation, and refolding of my predicted enzymes. I have identified potential fluorinase enzymes within these 3 bacterium. 2 of them being from the Actinomycetes clade, which is often the clade in which fluorinases are found because they are soil bacteria and there is a lot of fluorine in the soil, even though it is in a locked form. And my third option, which is Peptocococabacterium CEB3, because more recently there has been a chlorinase in Mythosamiata. It was identified as a chlorinase or labeled as a chlorinase, but however, through experimental research, it was found to be a fluorinase and the fastest acting fluorinase discovered thus far. So I'm also going to be I'm going to be purifying my enzyme using HIC and size exclusion chromatography. I'm going to validate the fluorinase activity of the putative enzyme using LCMS, and then I'm going to determine or research the optimal conditions for activity and the enzyme kinetics for all 3 fluorinase sources. Now, my methodology will include transformation via the heat shock method. So we had sequences created for us, plasmids created for us by Inqaba Biotech for all 3 fluorinases. And therefore, we're going to transform them into E. coli via the heat shock method, and then we're going to screen using PCR and restriction digests just to ensure that we do have positive transformance. For protein expression, we are going to use IPTG, obviously going to use expression trials to find out the optimal concentration of IPTG that needs to be used for expression. And then thereafter, we're going to denature, wash, and conduct lysis using buffers, and then further refold the protein via stepwise dialysis, and then thereafter purify, and then all analytes in each and every process in each and every step will be assessed using STS page. Now this is the canonical fluorinase reaction. As you can see in the image, it's SAM, acetylmethylmethionine. methionine. When reacting with fluorinase, when SAM is placed with a fluorinase and a fluorine source, it could be KF or NAF, you will find that it produces methionine and 5-fluoro-5-deoxyadenosine. Now that's what we're going to be using to test and see if our fluorinase is proceeding with the reaction as it should in order to be classified as a fluorinase. And we're going to assess 5-FDA formation using LCMS. Now I'm going to be validating the CF bonding forming ability and then characterize it in terms of thermostability, optimal temperature required for it to function, the optimal pH at which it functions, its enzyme kinetics to see if it's industrially applicable, and as well as the effect of metal ions on it. So thus far, I have transformed 2 out of 3 of my bacteria via the heat shock method, and I have confirmed positive transformance and created stocks therefore. And then I also ran bacterial growth trials to see the optimal time after inoculation in which I can in which I can inoculate with IPTG4 expression. I have also started with my refolding and or stepwise dialysis. You'll see pictured here 2 of my gels and a key up there for reference. So I'm currently working with 200 ml expressions of each of my putative fluorinases. And I am taking insoluble protein. I am subjecting it to a lysis buffer, to a wash buffer to remove any other contaminants. And then I'm going to denature my protein in order to refold it into its native state so that it can function properly. The one thing about fluorinases is that its quaternary structure is that of a homohexamer. So it is 6 distinct unit pieces that need to function in concert in order to catalyze the CF bond. So I need to accurately create or accurately refold so that I have enough native protein to continue with my experiments. So as you can see thus far, I start out with very large amounts of protein, but as you can see, some of the protein is lost in some of my steps. And you'll see for S. morkensis so far, my refolding has failed at times. So instead of having a clear solution at the end of my refolding process, I have had cloudy solutions which are indicative of aggregated proteins. And aggregated proteins or inclusion bodies show that the protein is not in its native active state. Therefore, I need to still continually optimize my buffers and the pH at which I use my buffers and the temperature and the buffer concentrations and components in order to effectively refold my proteins. Therefore, so for me to continue on to their purification and subjecting them to LCMS for characterization. So far I'm working with 200 ml expressions. Obviously I am going to scale up. Right now I'm just trying to ensure that I perfect my buffers to ensure that I have as little loss as possible. So I have more total protein within my solutions. So as you know, I'm currently still in the labs continuing with my experiments. So I'm optimizing my refolding or my stepwise dialysis steps. Thereafter, I'm going to optimize my purification steps and then continue on with LCMS analysis. Hopefully I can do some CD spectrometry as well within the lab, so that I can see the components within my protein and can compare it to the sequence that was seen on blast searches. And then hopefully, I hope in future to continue forth to use mutagenesis in order to increase my enzyme kinetics, to increase their flexibility, and to ensure longer storage in order for these fluorinases to be used industrially. Thank you so much for listening.
Thank you so much, Kanyesile. We appreciate your presentation. It was really interesting. We are just going to allow for 2 questions from the floor. Any questions for Kanyesile? Can I ask you a question, Kanyesile? I was just wondering, you were saying for the industrial use of fluorinase, so in which area does it get applied in the industry?
Oh, okay. So like I said, that incorporating fluorine into already existing drugs, for example, in the pharmaceutical industry, it tends to improve their binding affinities and their targets. An example would be perhaps with PET scans. The drug that they would use in order to visualize the cancer cells, it's fluoroglucocortisone. Yes. Fluoroglucocortisone is more effective or lasts longer and has a longer half-life than glucocortisone. So in instances like that, that is where I would like fluorinases to be the main method in which to fluorinate these products, instead of chemical fluorination.
Okay, so the fluorinase from the bacteria, you would say it's more safer to use, a safer option in terms of toxicity?
It's more of a greener option and a safer option, because if you work with fluorine gas, you know there's certain precautions one has to put in place in order not to allow the fluorine gas to escape and react with the air and cause an explosion, for example. So it's a much greener, milder, and more selective alternative. However, it still really has a long way to go before it is industrially applicable, because we need to look at the cost of using fluorinases versus chemical fluorination. We need to look at their pros and their cons. And so far, fluorinases are only winning in the fact that they are a greener alternative. That's why characterization is important. That's why discovering new fluorinases are important, because we need to increase the biological toolkit in which fluorinases can be industrially applicable. Did I answer your question?
Thank you so much, Kanisile. If we have no other questions, we can give a nice hand of applause. All right, and then we will invite Burenda for a presentation. So Burenda's presentation is on deciphering the genomic blueprint, whole genome sequencing of indigenous Venda chickens to provide insights into their evolutionary structure.
should just send it. Jesus. Can you just email it? Okay, what's your email quickly? I was emailing it to Tsebo. I got overwhelmed. What's your email? What's it? Let me just drag it. You want to copy it? Yeah. I was emailing. Province. Okay, and they are predominantly found in the Limpopo province, in the Wembe district. They are known for their adaptability to extreme temperatures, different temperatures, and different environments. What facilitated this research was that South African indigenous poultry breeds, they remain under-characterized, more especially in the genomics landscape. Another reason was that they face lack of conservation efforts, and also since they are under-characterized, that means that we do not fully understand their genetic architecture. That means that there is a possibility of that there could be uninformed crossbreeding with other chicken breeds, and this could lead to a dilution or a loss of unique genetic traits. So, collectively, if these factors are left unchecked,
they could reduce the breed's adaptability to environmental challenges, disease tolerance, and it could also compromise their cultural and evolutionary significance. So this project was driven by the aim as follows and a set of objectives. The aim was to generate a high-quality reference genome of the indigenous Venda chicken and to analyze its genomic structure so that you can improve our understanding of its adaptive traits and evolutionary relationships. So the set of objectives were to assess the genome structure of the indigenous Venda chicken through de novo assembly and to determine the functional structure of the Venda chicken through genome annotation, as well as to assess the evolution of Venda chicken through phylogenomics. So in order to achieve the aims and those set of objectives, we set out to carry out the methodology following the ethical guidelines, and the methodology started with blood samples. From there, we ensured that we are extracting a high molecular DNA, which is very crucial for this step, the PAC biosequencing. Since the studies about whole genome sequencing, which is a process of reading every single DNA letter inside an organism's body at once. So from that high molecular weight DNA, we subjected it to PAC biosequencing, and then we used PAC BioRevio and SQL, and from there we achieved a sequencing depth of 63 times coverage. So from there we got the go-ahead that we can continue with the analysis and with generating the de novo assembly, because that exceeded the benchmark for the de novo assembly, which is 50 times coverage. So in order to achieve de novo assembly simply means we're starting from scratch. There is no equality. Prior to this study, there was no a chromosomal level assembly reference genome of the Venda chicken or a South African indigenous chicken altogether in the NCBI. So we started from scratch. We built the map. We started with the hi-fi reads, as I indicated, and then from hi-fi reads we went to KEMA profiling. All this pipeline was being carried out at the Galaxy Europe workflow. So from there, we went to KEMA profiling to assess the genome profile scope. From KEMA profiling, we went to genome assembly. From genome assembly, we went to patch duplicate contigs. And then from there, we went to high-C scaffolding. From scaffolding, we were using high-C reads because we wanted to reach a chromosomal level assembly. After scaffolding, we had to do assembly decontamination so that we can remove contaminants or any DNA that does not belong to Venda chicken. From there, from those sets of pipeline, we achieved the results as follows. So starting with genome scope profiling, before we attempted to do further analysis, we wanted to understand, or how does this sequencing, how does what we have, the hi-fi reads, relative to what is known in the avian landscape, how does it compares and how does it estimate the genome size? So we wanted to know if we will get duplication rate, we wanted to estimate the genome size, we wanted to know the heterozygosity. And then we did the KEMA profiling at K21. From there we got a 0.15 error rate, and then the estimated genome size was around 1.1 gigabyte. So that gave us a go-ahead for a quality and accurate analysis. From there, as I mentioned, that there was purging, also scaffolding, decontamination, and curation. These are just the pretext map showing you that from high-C scaffolding, we got this pretext map which was fragmented. So we had to clean that using decontamination. After decontamination, we realized that we cannot continue with that. It's still fragmented. There's still loose pieces in some places. So we went ahead and used pretext map we manually curated the assembly to ensure that we have a high quality assembly at chromosomal level assembly. So from there, we took our assembly, we compared it to other published genomes at the NCBI. We realized that we achieved a high quality assembly because it's 1.1 gigabyte. It is consistent with the other reference genomes. We also realized that our L50 of 4, that means that the largest scaffold together, the 50% of our genome is the largest scaffold together, they constitute to 4. So it reflects a high quality assembly which is continuous and non-fragmented. So from these statistics, we also make sure that there's no bias. The assembly is still of high quality. We check the BASCO score. The BASCO score is used to provide an assessment of the assembly and to check its completeness. So it aligns the vendor genome against other IVN databases, and we got 97% completeness with only 227 missing. So from there, we had to answer the biological questions, the functional annotation, and comparative genomics. So this part, we needed to understand how does our indigenous vendor chicken differ from the other poultry breed. So we carried comparative analysis using OrthoVen3. From OrthoVen3, we were comparing vendor chicken with Tibetan, the Silky, the Naked Neck, the Ross, the Cornish, and then using the Bigalgal. That is a reference genome, as a reference genome. And then we realized that we identified 15,560 shared ortholog clusters, as well as single copy orthologas, which are 5,426. These are just single copies which are found in every genome, in every organism. They carry through the basic functions. However, interestingly, we realized that our vendor chicken has 381 unique clusters. So we wanted to ensure that there is no bias and that was valid, is not a misartifact, is not an analysis problem. So we analyzed that using geo enrichment. So we checked the functional validity of that 381 unshared clusters. Then we performed functional enrichment, and then we realized that we have an over-representation of survival pathways in that 381 clusters of unique, which is unique to vendor chickens. So that included heat stress. It also included adaptation to immune response. It also included scavenging commitment, which was demonstrated by the clusters 17769 and 1651. And as we can see on literature, we can see that they say that vendor chicken, it has good scavenging abilities. So this could suggest that the good scavenging abilities, they are also driven by their genetic traits. So from there, because we wanted to ensure that there is no bias and that what we were seeing was validated, we took that protein and took it for validation. When we validated it, we took it to NCBI, we blasted it, and we realized that it is identifiable and it has hits. It's identified with titin isoform X2 as demonstrated by the diagram there. So from there, we had to take it further and do variant calling. So we wanted to make sure that once we have the functional validity, we wanted to understand, or where does what is the exact locations of those, and how does Venda chicken differ in their DNA code relative to other animals. So we did variant calling, and this is an evolutionary tree. It demonstrates that Venda chicken, as you can see, the branch is 2.50. So it's demonstrating that Venda chicken has, in comparison with other chicken branches, it could be suggested that Venda chicken still retains some of the genes. It has not been contaminated, or it has not been diluted by commercial genes or exotic genes. So after combining these findings with the comparative orthologous analysis, it could also be suggested that the Venda chicken's observable climate resistance is built on unique evolutionary foundation. This is exactly why maybe we also got 381 unique clusters when we were doing orthoven analysis. So, since the tree demonstrated that the Venda chicken breed represents a separate or unique divergence, it was now important to know where the millions of genetic differences lie along the chromosomes. So to answer this, we had to generate a genome-wide SNP density map. So this map looks at the variance of the 5 breeds, chicken breeds. However, the difference here is that we did not use the B-gal-gal reference genome. We used Venda chicken as a reference genome. So from there, after we did the pipeline, we had 12 million variants, of which 12.1 million are single letter SNPs, and then 744K are structural indels. So as you can see on the tree, the x-axis, they measure the horizontal length of the chromosome in base pair, and then the y-axis, they demonstrate the chromosome name. So from there you can see we took the largest scaffolds. We took from 1 to 30, and then from there we analyzed the genome-wide SNP density using computer tools. And then, as you can see from the bottom, the colors show the density of the mutation. This is the places where the other breeds differ with Venda chicken. So from the cream white here to the green until the bottom, it shows the intensity of the mutation. So the bright red here, as you can see, they are yellow and there are also bright red spots. This one, they demonstrate high variance, and the highest number of high variance demonstrated by red part, it carries 25,800 steps per megabase pair. And then also to validate that our data was correct and that what we were looking at in the genome-wide SNP density map was actually accurate, we checked the sequencing depth. We learned that from the sequencing depth, if it's about 50, since we achieved 63 times coverage, it means that tools like BCF and other computational tools are able to cleanly separate true SNPs from sequencing artifacts. We also did an analysis of the TSTVs. Those are the transitional to transversal ratio. So we realized that we have 2.21, and then from there we could conclude that our SNP density is of high quality. So I would like to acknowledge UNISA. I would also like to acknowledge my supervisors and the Africa Biogenome Project, and also would like to state that we achieved a high quality reference genome and we were able to do the downstream analysis, and that this project do not only demonstrate the power of whole genome sequencing technologies and bioinformation in addressing biological questions, but it supports the South African NDP 3030 goals and also the SDG goals, the Zero for Hunger goals, as well as the SDGs 13, the climate action, because we are trying to facilitate conservation, also trying to find ways to improve livestock while retaining their sustainability in a changing climate. Thank you.
Thank you so much, Brenda, for an interesting presentation. I'm going to open the floor for questions. Questions for Brenda? Nobody has any questions. Ntabi, yes.
Thank you for your presentation. I saw on your genome-wide SNP density map, you only shown 30 chromosomes. What about the rest? Because initially you have indicated that there's 40 chromosome pairs in cattle. I mean in chicken.
Yes, there are like 41. However, what we were looking at here, we looked at the largest scaffolds. So when we look at the largest scaffolds, it means that if there's a mutation, it is most likely contained in those largest scaffolds. And to validate that we achieved the right variation within those large scaffolds, we verified using the TS-TV's analysis.
Okay, and also on the phylogenetic tree, so those numbers on that tree, what do they indicate? The 2.499, are those years or centuries, or are they what?
Okay, the numbers are distances. These are the branches of the phylogenetic tree. So the 2.49 you see here, it is the distance, it's the branch distance. And then if you look at rows, the number is almost zero. It's 0.0000, and there's a 1 at the end after this. There's so many decimals. So these numbers, they represent how Venda chicken then branched out, or rather how the other chickens in comparison branched out from Venda chicken based on the mutations. So it could also suggest that these other chickens, as you see, Rose is a commercial chicken. It could also mean that it had went through a lot of selective breeding. They've been breeding them for different favorable traits, production traits. So that's why there's a lot of numbers here and differences. They show the distance in branches.
All right, that's very interesting. One last question from me. Why didn't you include the Galgal-1 reference genome for your comparison year?
For the variant calling?
Yes, for in your evolutionary tree.
For the evolutionary tree, because my thought was that because B Galgal-1 it's used as a reference genome, and it has been characterized comprehensively, I wanted to map this against Venda chicken to see how they differ, how the other chicken population differ relative to Venda chicken.
Okay. All right. Ray, one last question from Ray.
Yes, thank you very much for your presentation. I just had a question also on the phylogenetic tree. Just to caution, to say that evolutionary trees are slightly different from phylogenetic trees, where there's a measure of genetic distance rather than a measure of evolutionary time. So just maybe just read into that a little bit. And just a question on the outgroup that you've selected. I see that there is a outgroup branch for your tree. Could you maybe just specify what you used as your outgroup to help for the clustering?
Can you please repeat the question?
So it's just the last one was the question where on your tree there is a tail basically at the very base of the tree. So I just wanted to find out what you've used for your outgroup, essentially the specimen that is at the base of that tree, because that will also influence how the species cluster together.
Oh, I was supposed to also use an outgroup, like sort of an outgroup species, to see how the breeds within one species diverge.
Yes.
Okay, I'll take that into consideration because I had only included the galas here.
Okay, no, it's perfectly fine. I think it's a good learning process, and it will just help to sort of get a better understanding of the genetic distances between relative to non-related species, so that you can better see how they cluster. So yeah, thank you.
Okay, thank you for the questions and comments. I'll take those into consideration.
All right, thank you so much, Brenda. We can give her another hand of applause. All right, so we are a little bit early for our lunch session, but could we check if the other three presenters are here? Mutanda, Poku. I think Mutanda is online, right? Is she online? Or he? And then...
Okay, Mutanda is online. And then...
Poku and Hosima.
Well.
Are they here today? And then also the other two speakers that were not here earlier on, did they maybe arrive in the meanwhile? Makala Peto and Matloa, did you guys arrive? You're not here today. Okay, so we can continue without them. All right, so now we're going to be breaking for our lunchtime and poster viewing. So we are a little bit earlier for our lunch. We are like 13 minutes earlier for lunch. But I think we can use that extra 13 minutes to do the poster viewings. If there are, I saw one poster earlier on. Not sure if there are any other posters, Tsepo. So we can do then the poster viewing during lunchtime. So then we will break for now for lunchtime. We're also supposed to do a photo session. When are we doing the photo session? Is it fine? Can we do the photo session now during lunchtime? All right, so we can break for lunch. It's now 12:44, so then we will have a very long lunch session for
Details the kind of customer-centric focus that we have in terms of the products that we provide and the service and support that comes from our team. Making sure that we are always at the top of industry-leading scale advancements, and we are reaching the depth of capabilities that you guys require, regardless of the question that you are trying to answer. Excuse me. Okay, so I'm just going to go into a bit of an overview of two of the divisions. As I mentioned, we're from the Life Sciences Group. We are one facet of Thermo Fisher as a big machine that has multiple different divisions that support different disciplines. My colleague Dinao over there is from our Biosciences division. And here, this is really the beginning of where you would start with the kind of questions you would be trying to answer. So from the time you get your sample, regardless of what that sample is, you'd obviously have a need to extract your nucleic acid, whether that's DNA or RNA. We are able to support you with both manual or automated solutions. So depending on your scalability needs, the kind of workflow that you are looking for in terms of the depth of how many samples you're looking at, how quickly you need to get things processed, you would either go with a manual solution or an automated solution. So we provide our Kingfisher range of automated extraction systems that are able to support from 24 head to 96 head automated extraction systems that you would then script to the particular extraction kit that you are using. Then anything from your quantification of your DNA, your amplification of your DNA with a range of different thermal cyclers. I'm sure a lot of you have seen some of the instruments on this slide, from the power snaps, the e-gel systems. I know a lot of you guys really love the precast gels that we are able to provide with our gel dock systems. And then anything after that that you would then try to take further with any real-time PCR work, Sanger sequencing, next-generation sequencing, CRISPR-Cas9, cloning and expression, as well as high-throughput SNP genotyping with your microarrays. So really just complete solutions that you would be running in any molecular lab. So whether it is there a question? Oh, no. Whether it is the molecular biology work, like I mentioned with the thermal cyclers, whether you are looking specifically at proteins, synthetic biology, cell analysis, with any fluorescent labeling and detection, we are able to support you not just from the reagent point of view, also from the instrumentation, and very importantly, the after-sales support with how we are able to hold your hand through the different projects that you are running with the best technical expertise within our field application scientists team. So I think the versatility is a very important thing, and that's why I mentioned earlier that I think the workflows we supply really fit in nicely with the different amazing work that you guys have presented today and what you guys are doing. So whether you are dealing with biological samples, serum, whole blood, swabs, saliva, we are able to support with a recommended extraction kits in order for you to get the highest yield and purity of your DNA or RNA. Yeah, so as I mentioned, the full workflow would be entailed here, and that would start with your particular sample. Then we can move on to the Genetic Sciences Division. This is the division that I am a part of. And this would be what you would be looking at downstream of your endpoint PCR. So if you are looking at doing anything regarding real-time PCR, where you're looking at quantification, both quantitative and qualitative results of your nucleic acid, we'd be able to support you with a range of different real-time PCR instruments. And we really view this as an ecosystem because the one part can't exist without the other. So we can support you with a range of off-the-shelf assays that we have. We currently have over 20 million pre-designed assays in our inventory. And what that means is you're essentially getting a single tube that contains both your forward, reverse primer, and your probe sequence. This comes along with the recommended master mix for that particular application, whether it's gene expressions, genotyping, whether it's just a presence absence, we'd be able to support you. Then, as I mentioned with the instruments, depending on the throughput needs that you have and also the multiplexing needs, we have a family of QuantStudio instruments that can support you from whether you're looking at doing tests with up to 3 targets that you want to multiplex, or whether you're looking at over 12,000 data points, we are able to support you with the instrument that would speak to the kind of project needs that you have. I think a really great part of this is also we find that customers may start with a smaller instrument, but as their lab grows or the work that they do grows, they find themselves needing more capacity. And we're able to then support them with our trade-in program, which allows you to upgrade the system that you have to getting one that would more support the needs that your lab currently has. And then a very big part of that is the service and support. Like I mentioned, once you have purchased the instrument or the reagents, we do have a team of service and field application scientists that are able to support you with your specific applications, with your workflows. They're able to give you great recommendations of really easy, efficient ways of doing things. And so I think customers really love having that support and having full access to these on-site members of our team who can actually come in the lab and help you on a wet lab basis with whatever needs you have. Within the universities, we do a lot of training actually for different labs. We're currently looking at some gene expression workflow trainings where we come in for like a week and we run you through both the theory and the practicals of how to do gene expression assay on the instrument. So whatever the particular need of the particular lab is, we'd be able to support you. And then I just want to briefly go into one of our MPI's new product initiatives. It's called the QuantStudio Absolute Q Digital PCR System. And with this system, essentially, we are supporting you on any workflow where you have a difficult sample. So if you have samples that you find the target within the presence of that sample is very difficult to get, and relying on a relative quantification such as real-time PCR, where you need a standard curve, is very difficult to get a result and you don't have much confidence in that result, there may be a need for looking at something like digital PCR. And here, essentially, we are taking a single qPCR reaction and we're breaking it up into over 20,000 individual reactions to ensure that we're looking more at like the needle in the haystack, where we can definitely find the presence of your particular target. And there's no need for relying on a standard curve here. Just to look at some of the applications, we have customers looking at cell and gene therapy, a lot of oncology work where you'd like to look at small changes that are taking place over time with the different oncogenes that are developing within the sample, environmental surveillance, especially I think at the tail end of COVID, we're seeing a lot of studies being done on wastewater treatment, where we're looking at trying to see what's the burden of particular pathogens on wastewater within communities. Very difficult to do this if you're going to be looking at real-time PCR. You can imagine getting any random sample of wastewater. The presence of that target is going to be very minimum. So relying on a standard curve could result in you getting a false negative, whereas with a digital PCR, you are guaranteed to find the presence of that target if it is within that sample. And then we have our laboratory products division, and these are the run-of-the-mill instruments, equipment that you would need in any lab, centrifuges, fridges, freezers, vortexes, anything from something as small as a pipette all the way to CO2 incubators. We're able to support you through our distributor partners. And then we can also support you with Sangha sequencing. So here you'd be looking at your targeted sequencing. And again, I think scalability is a very big part of the focus of the different instruments that we supply, whether it's a small lab looking at doing very small quantity single gene analysis, and you want to target those specific genes and do fragment analysis, for example, we're able to support you with a 4-capillary instrument all the way to being able to run thousands and thousands of samples in a working day. Just to look at some of the capabilities in terms of the applications here, anything from your human identification and forensics work, a lot of infectious disease work being done here, microsatellite instability, oncology, epigenetics, confirmation of next generation sequencing, we'd be able to support you. And again, I think a very important point here is we wouldn't just support you with the reagents and the instruments to run, but also with the after-sales support in getting that technical support from our team, regardless of what particular application and workflow you are looking at. And then just an overview of our team that supports you as UNISA. From our different divisions. You may have met some of us here, but this really spans from our biosciences division, our genetic sciences division, our field application and service team, as well as our animal health, and I think that would be applicable to quite a few people that we have interacted with today. We have a special team dedicated to supporting animal health specific workflows. They've had a very big role in the current FMD crisis that we've been having, and so we're really able to support you from extraction of your samples all the way to the sequencing of those particular targets. Thank you very much. I hope I was within my time.
Thank you so much. No, you did well. Thank you so much. Colleagues, any questions? Comments? It's also mentioned that whoever asks the question will get a discount.
We're actually running a lot of promos at the moment, so please feel free to reach out to us. And we'd love to interact with anyone we haven't already by our stand. So good to meet all of you guys.
Okay, it seems like they are all happy. Okay. I don't see any question. And I don't know, is it possible to also have your slides?
Yes, absolutely. I've already actually shared them with the team. So.
Okay, thank you so much. Thank you again. Thank you so much for an interesting talk. Okay, our next presenter, I was told that he was online. He or she, please, sorry if... Mutanda, are you ready? Is Mutanda available online? Mutanda, we ready for you? We don't have Mutanda online. Okay, the next speaker, I was told that she will opted to do the poster, which we will ask if Jay-Z Poku, if you are ready online. Jay-Z Poku, colleagues, if you can see Poku. Jay-Z Poku, are you there? Oh. Do we have Josia Mang?
Yes.
Okay. Are you ready to present? I don't have your title here. If you can just project your presentation, please. Okay, our next presenter will be Ompile Khosiemang, who will be presenting under the title of Prevalence of Neospora caninum and its associated risk factors in cattle farms from selected districts in the Limpopo province. You can start when you're ready. Are you ready?
Please, can you hear me? I'm ready.
Yes, we can hear you, but we can't see your slides.
Please let me know once you see it.
Okay, now it's there. You can carry on.
Good afternoon, colleagues. I'm Umpila Khosiemang, and I'll be presenting results of my study, which is titled Prevalence of Neospora caninum and its associated risk factors in cattle farms from selected districts in the Limpopo province of South Africa. Neospora caninum is a complex and protozoan parasite that causes neosporosis, a disease of cattle and dogs. Neosporosis causes significant economic losses in the meat and the dairy industry, and then its losses are estimated to $12,200 million annually. The annual global cost of Neospora related to reproductive failure is estimated to be $1.3 billion. We see symptoms of Neospora caninum in dogs and cattle. And caninum causes vertical calf infections, stillbirth, and repeated abortion in both dairy and big cattle. Clinical signs in dogs can include paralysis, muscle weakness, and tremors. And in older dogs, we see inflammation resulting in muscle weakness. Seroprevalence studies have been done in Africa and in South Africa. We see that Kenya reported a 5.7 seroprevalence, the highest. Kenya reported a 24.1 seroprevalence, while Namibia reported 5.7 and Senegal a seroprevalence of 3.7. In South Africa, there's a few studies, even though caninum is not widely researched, but we have a few studies that have been reported on seroprevalence of caninum. We see in 1995 there was a study that reported 1.3% of seroprevalence in diagnostic samples. In 2011, there was a study that also found in hunting 8.9% of seroprevalence. There was another study that was done in various provinces, and Northwest came out with the highest seroprevalence of 25%, KZN at 17.9. Here is just a representation of seroprevalence in Africa in cattle. We see Senegal coming in at 3.7, the highest will be in Sudan of 16%. Moving on, this is also a representation of what we just spoke about, the seroprevalence in South Africa in cattle. We have various species, we have seroprevalence of caninum in various species. There's in goats, there's a seroprevalence of 3.1, in wildlife we see 16.7 in the conventional, and in dogs there is a high seroprevalence of up to 45.2%. We have come up with research problems that caninum is a clinical pathogen in South Africa, and its role in causing abortions might be underestimated. Despite its impact in the economy, there are factors that might be contributing to its spread are not fully understood. Key elements such as the role of domestic dogs, stability hosts, the weather, the environmental exposure, they may influence the prevalence of infection, yet they are not fully explored. We've come up with two objectives. The first one is to determine seroprevalence and geographic distribution of caninum in cattle of the Limpopo province. The second one is to also determine the associated risk of transmission of caninum. The hypothesis is that Limpopo province would have a high seroprevalence. Here's our sample design. So for our study, samples from a study on Coxiella donating were used, and a structured questionnaire was given on management system and association risk factors. Due to FMD restrictions, Limpopo has 5 districts, but because of the restrictions, only 3 were sampled. Vembe and Mopani were restricted. The districts that were done is Capricorn, Waterberg, and Sekukuni. A total of 384 samples, animals were sampled, and out of these we got sheep grapes, vaginal swabs, and syrup. Here's our sampling criteria. Adult cattle were used, both bulls and cows. Animals from farms in the chosen municipalities, cattle that appeared to be in good health. The only exclusion was that sick cattle and cows were excluded. So the sampling criteria is that if a farm or a dig tank had over 50 cattle, a maximum of 20 cattle would be sampled. If a farm or a dig tank had less than 5 cattle, then all of them sampled. Moving right along, for our sera, we tested with ELISA. We subjected our sera to ELISA assay using the Neospora antibody test kits. The samples were tested in duplicate and they were done according to the manufacturer's instructions, and below there is an interpretation of results and how they were calculated. Moving on to our results, the apparent seroprevalence of virus provinces is 10.9, showing us that 42 out of 384 animals tested positive for Neospora capenna. At district level, we see Sikupini coming in at 13.3, followed by Waterberg with 6.25%, Capricorn at 3.3. And when we take it down to deep tank or farm level, out of the 20 deep tanks that were sampled, 60% tested positive for N-caninum antibodies. We further subjected our results for univariate analysis using the chi-square. The initial inclusion criteria was less than 0.3, and then all the factors were then considered for univariate analysis, and all the variables were statistically insignificant. They all were above the P, they were all above the 0.05. Here is a table that represents the P values of the risk factors that were analyzed. None of them were statistically significant. Although some variables had lower P values during the screening stage, none were statistically significant after the univariate analysis. Then when we come to our apparent seroprevalence remains at 10.9, indicating that cattle in Limpopo province have been exposed to the parasite. This finding confirms that the presence of N-caninum in the study. This confirms presence of N-caninum in the study population and contributes to the epidemiological data for the province. The seroprevalence was broadly similar to some studies, but varied across regions due to factors such as education, management practices, production system, and sampling strategies. Because all of these factors were significant, this suggests that the variables evaluated in this study were not independent predictors of N-caninum exposure in the sample population. The absence, however, does not necessarily mean that the risk factors do not exist. Within this study, there was insufficient evidence to demonstrate a statistically significant relationship between the investigated variables and N-caninum seropositivity. This may also reflect the cross-sectional nature of the study, the sample size, or the possibility that other important epidemiological factors were not included in the questionnaire. So overall, these findings highlight that N-caninum is present in Limpopo province and emphasizes the need for continued surveillance and further studies to better understand the epidemiology. Limitations, we had limitation when it comes to our sample. Samples were collected from deep tanks, but this may not fully represent the entire cattle population in the Limpopo province, since animals that were not brought to the deep tanks were excluded, and this could affect the representativeness of the estimated seroprevalence. But in conclusion, this study demonstrated that cattle in the Limpopo province have been exposed to N-caninum with an apparent seroprevalence of 10.9. Although the risk factors identified were not significant, they provide valuable epidemiological data and support continued surveillance and further research to improve our understanding of the parasite in South Africa. I thank you.
Thank you so much for your talk, interesting talk. Colleagues, do you have any questions for her? Any hand? Online? We don't have anything online. Okay. I just saw something that you said in your selection criteria. You selected animals, those are diseased.
I'm struggling to hear you. There's no sound on my side.
Hello?
Can you hear me?
Yes, I can hear you now. You were saying? Can you hear us? Hello? Pile, can you hear us? Colleague seems like she's struggling to hear us.
I can hear you.
Oh, okay.
I can hear you now.
Oh, okay. Yeah, I was just saying I noted that you, in your the selection process for the animals, you said you selected those, you excluded the ones that have a disease, and you included the one that looked healthy. How do you, what does looking healthy mean? Did you use any veterinary method to determine that they look healthy, they are healthy? Hello? Did you get that? Ompile. She muted. Can you unmute, please?
Alex, can you hear me?
Now we can hear you.
Can you please repeat the question?
Okay, I was saying in your inclusion and exclusion criteria, you mentioned that the animals that you selected the ones that looked healthy. Can you explain what does looked healthy mean? Did you use any scientific method to determine that they are healthy?
No, there was no scientific method that we used to determine if the animals were healthy or not.
Okay. Yeah, I just wanted that clarity on my side. I don't know, colleagues, if anyone has the follow-up questions for her, or seems everyone is happy, and thank you for your time. Can we please give her a round of applause again? Next, do we have Snenze Oyandi? Online, do we have Snenze Oyandi? Or anyone that I passed before? Mutanda, Poku, none of them. Okay, colleagues, that means today, I don't know if it's a good thing that we finished our program earlier to avoid traffic going back, but I would like to thank everyone for the inputs to assist the students where they are. And we should always remember that they are in the learning curve, so whatever guidance we give should be constructive to help them going forward. And we appreciate the students also for making time to come and have courage to share whatever you're doing, you're working on. You should always remember that whatever you're doing, we are here to assist. This is the only opportunity that we have to see what you're doing and to have input. To assist, all the inputs are meant to assist you going forward. And again, colleagues, much appreciative to you, all of you, to make time during this cold and busy time. And with that, I would like to end the day and say, or before I conclude, just give me a minute. Okay, and also the poster presenters, the judges who are asking if you can go stand next to your posters just for 5 minutes or so before you leave. And we'll see you tomorrow. And please take care. We know what is happening outside there. If it's difficult, don't force. We will communicate the alternatives, but if you can, we will be here. And everyone stay safe out there. Thank you.